Question 3, we are given 4 resistor, R1, R2, R3 and R4. We connect to a battery. A voltmeter is connected in parallel to R3. So we have a voltmeter. The voltmeter is connected parallel to R3. So it means that this voltmeter will measure voltage across R3, okay? Sebab voltmeter tu sambung parallel to R3, so it will measure the voltage across R3. So this voltmeter showing a reading of 6 volts, so we understood the voltage across R3 will be 6 volt, okay? Daripada maklumat soalan ni. Determine the current I draw from the battery. So we want to find the current I. So the current I is the current that flow out from the battery, whereby this current will be supplied to R1, R2 and R3. So it means that this current is referred to the total current in the circuit. Okay, so kita nak cari I. So kalau kita nak cari I, then kita understood battery ni ada voltage V. So kita boleh relatekan V dengan current gunakan Ohm's law, equation 22. V equal to IR. We have equation 22. Okay, so the V is referred to the voltage of the battery lah. So V here is the voltage of the battery. I is the current that draw from the battery, the total current that flow in the circuit. So since current ni adalah current yang keluar dari battery, it will be supplied to all of the resistor. So it means that R di sini adalah refer kepada total resistance, or we call effective resistance. So the V is the V of the battery. So kalau kita nak cari current that draw from the battery, kita mesti dapatkan berapa voltage of the battery dan juga the total resistance of the 4 resistor that we connect with the battery. Mungkin kita perlu dapatkan effective resistance ataupun total resistance dululah. So macam mana nak dapatkan total resistance? Ni adalah satu jalan. Dan this is a junction. Ini adalah satu jalan lagi. Then this is another junction. So ini satu jalan. Okay. So you boleh nampak obviously bila anda colorkan macam ni, you will see obviously R3 and R4 is connect in series. Kenapa series? Sebab dia duduk jalan yang sama. Dia duduk jalan yang sama. See? Color dia sama. So, lepas tu, combination of R3 and R4 will be parallel to R1 and R2. Dia parallel kepada R1 dan R2 sebab ketiga-tiga ni mereka duduk pada jalan yang berbeza. Okay? Path yang berbeza. So, kita akan mula kira dulu kita punya effective resistance R total. So kita cari dulu R total, kita mulakan dengan R3 and R4. So the R3 and 4 will be R3 plus R4 sebab dia series. So 4 plus 10 we get 14 ohm. And then tiga bahagian ni adalah parallel. So we have 1 over R total. Sometimes we call it R effective. Will be 1 over R34. Bahagian yang combine ni. Plus with 1 over R2. Plus with 1 over R1. So we have 1 over 14. Plus 1 over 9. Plus 1 over 5. So we get 1 over R total. So kita selesaikan untuk dapatkan R total. The effective resistance, the total resistance of the circuit. You akan dapat is around 2.61 ohm. Lepas tu kita dah settle yang effective resistance. But then kita kena dapatkan voltage of the battery. Voltage of the battery. Kalau tidak, kita tak boleh nak dapatkan current that draw from the battery. So macam mana dah dapat voltage of the battery? So anda boleh fokus kepada bahagian ni yang teacher colourkan hijau. You perhatikan. Bahagian ni dengan battery ni adalah parallel. Jadi voltage of the battery adalah voltage yang kita supply kepada resistor 4 ohm dan juga 10 ohm. Okay, so teacher lukis kat bawah. Saya redraw balik. See? So bahagian ni adalah voltage of the battery. V battery kita. So our voltage of the battery is given to 4 ohm and 10 ohm, which is connect in series. Dan kita tahu, kita pasang voltmeter di sini dan kita dah measure voltage across 10 ohm ni adalah 6 volt. So I can calculate the current. Saya boleh dapatkan current yang flow ni. Yang flow melalui 10 ohm. So I have V equal to IR. So the voltage is 6 volt. The resistance 10 ohm. So saya dapat current that flow through the 10 ohm resistor is 0.6 ampere. Okay. Dan kita understood R4 dengan R3 ni connect in series. So, kalau kita recall konsep dalam direct current circuit, for any resistor connect in series, they will have same current. They will have same value of current. So, maksudnya, current yang lalu 4 ohm pun adalah 0.6 ampere. Okay, it's 0.6 ampere, sorry. So, I can calculate the voltage across the 4 ohm resistor. So V equal to IR. So teacher boleh cari V4. Voltage yang lalu R4. So I will have 0.6 multiplied 4. So saya akan dapat 6 times 4, 24. So 2.4 volt. Okay, kita dapat voltage across here is 2.4 volt. 2.4 volt. So, kita nampak voltage of the battery is divided to 4 ohm resistor and 10 ohm resistor. Dari situ kita bolehlah cari voltage of the battery. So, the voltage of the battery will be the voltage across R4 plus with voltage across R3. Recall concept dalam direct current circuit. Untuk resistor connect in series, their voltage will be divided. So kita dapat 2.4 plus 6. So the voltage of the battery will be 8.4 volt. Okay, so after we get the voltage of the battery, we get the total resistance in the circuit, then we can determine the current I that draw from the battery. Draw from the battery means flow out from the battery. So, barulah kita pergi balik kepada equation paling besar dekat atas ni. So, V battery will be the current that draw from the battery multiplied with the total resistance. The total resistance. So we can get the current that we draw from the battery. So it will be 8.4 divided by the total resistance 2.61. So we will get the current that draw from the battery will be around 3.22 ampere. A copper wire with resistivity. Okay, terus letakkan simbol dia. Rho 1.68 to the power of negative 8 ohm meter So I have a wire. The resistivity is 1.68 to the power of negative 8 ohm meter. The length of the wire L is 12.5 meter, and the diameter of the wire, so the diameter is 2 cm. So the cm have to change it to meter. Is connect in series to a 5-volt battery at 27 degrees Celsius. Okay, this wire we connect to a battery. Whereby the voltage of the battery is 5 volt. So very starting, the temperature is 27 degrees Celsius. So the temperature coefficient of resistivity of copper is 6.8 to the power of negative 3 degrees Celsius minus 1. So class, if you recall the concept, we understood our R will vary with temperature. Kalau you recall konsep yang kita belajar dalam topik 3, kita punya nilai resistance varied with temperature. As temperature increase, when temperature increases, the value of resistance will increases. The value of resistance increases. That's why the question gives us the temperature coefficient of resistivity. That one ialah alpha. 6.8 to the power of negative 3 per degree Celsius. Okay, so question 1, calculate the resistance of the wire at 45 degrees Celsius. So I want to find what is the resistance at temperature 45 degrees Celsius. At temperature 45 degrees Celsius. So saya punya resistance varied with temperature. Jadi, saya nak cari final resistance when I increase the temperature. So, kalau kita refer kepada konsep dan equation yang ada, kita boleh relate the final resistance at final temperature using equation 24. Equation 24 is the equation for the variation of resistance with temperature. So kita dah kenal pasti. This is the equation I'm going to use for this question. So kita tulis dulu. To find the resistance at 45 degrees Celsius, so I'm going to use this equation. R equal to R naught in bracket 1 plus alpha T minus T naught. Okay, so kita nak cari resistance kita pada temperature berapa? 45 degrees Celsius. T naught ni ialah apa? T naught is the initial temperature lah. The initial temperature given in the question is 27 degrees Celsius. R naught is the value of resistance lah pada temperature 27 degrees Celsius. But then, the question didn't give us the R naught. The question didn't give us the R naught, but the question gave us the resistivity, the length of the wire, and the diameter of the wire. So, how we relate R with resistivity and length? That one kita kena guna satu lagi equation. For any wire of length L with resistivity rho, cross-sectional area A, kita boleh relate dengan resistance gunakan equation 23. Resistivity is RA over L. So, kita tahu kita boleh cari nilai resistance R naught ni gunakan equation tersebut lah. So, kita tulis dekat tepi. Kita akan guna juga satu lagi equation ni. Rho is RA over L. So, saya gantikan ke sini. So my R naught will be rho L over A. Kita susun balik lah equation tersebut. So R naught will be rho L over A 1 plus alpha T minus T naught. R. Then kita mula gantikan semua nilai lah. So the resistivity 1.68 to the power of negative 8. The length of the wire 12.5 over, the area is not given, but we understood when we are given the diameter means the surface is round, so kita boleh cari area whereby the area is pi r squared. Bulatan kan? Bulat kan? Pi r squared. R adalah diameter bahagi 2. Diameter bahagi 2. So kita boleh teruskan di sini pi. So 2 to the power of negative 2 tukar kepada meter, divide by 2 sebab diameter bahagi 2 baru dapat radius, kuasa 2 pi r squared. Okay, in bracket 1 plus alpha is the coefficient of resistivity 6.8 to the power of negative 3. Then we have 45 minus 27. Okay, the change in temperature T minus T naught. Then we do our calculation. We will get the resistance of the wire at 45 degrees Celsius. So, kira dulu nilai ni. I get around 6.68 to the power of negative 4. Dia step kita banyak sikit tapi kita tak salah. Jangan sekali tekan kalkulator lalas kita dapat syntax error. Lagi buzzer masa. Kira satu-satu. So I get this one 0.1224. Kan macam ni kan senang. Nanti kita dapat nilai R. Then we get our resistance 7.5. I round off lah. Times 10 power of negative 4 ohm. Unit jangan lupa. Our answer must follow with unit. No unit, no marks will be given. Then number 2, if the wire is replaced by a longer identical copper wire, does the current decrease, remain unchanged or increase? Explain your answer. So class, we replace the wire with a longer wire. Identical means dia masih buat daripada copper, dia masih ada diameter yang sama, tapi panjang dia berubah. We change with a longer wire. Our L increase. So the length of the wire is increases. So the question asks you, the current will decrease, remain unchanged or increases? Explain your answer. So anda kena faham length tu dia akan mengubah nilai apa. Jadi kalau kita refer kepada formula yang ada, our R is rho L over A. Nampak? Susun balik dari equation ni. So from the equation, R is rho L over A. So we understood our resistance of the wire is proportional to the length of the wire. So when you have a longer wire, it means that we are going to have greater resistance. Sebab dia directly proportional. So greater the L, greater the R. Then try to relate, but the question didn't ask about the resistance. The question asked about current. So you have to relate the current with the resistance. So according to Ohm's law, V equal to IR. So I is V over R. So you can see obviously the current is inversely proportional to the value of resistance. It means that when your resistance is greater, what happened to our current? The current will be smaller. So our current will decrease. Current kita akan berkurang. So we will have the answer, current will decrease. So current will decrease tu adalah jawapan kita lah. So jawapan kita current will decrease. Explanation kita, ini explanation kita. Dalam fizik kita tak perlu tulis ayat yang panjang-panjang, tapi kita explain gunakan equation. Daripada equation kita tengok hubungan dia. Dari situ kita dah explain. Normally kita mesti tulis explanation dululah, barulah kita boleh draw a conclusion apa jawapan kita. Okay, so this is our explanation, then this is our answer. The current will decrease.